All right, guys. Great question. Somebody had a question. I forgot your name. Sorry, but you had a question about in behavior or rational function. So I thought I would just go to the site. There's several ways to look at this, but to make a long story short, you're looking at what happens to this graph as x goes to the left. The negative infinity means as it goes to the left, and positive infinity means as x goes to the right. It's either going to be going high. Let me do a very simple example. I love using Desmo's graphing calculator. It's a good way to visual. And it's a graphing calculator that you can use, and it's free. If you have your own graphing calculator, use that, okay? All right, so here I'm at a graphing calculator. Let's go to the simple function x squared. The end behavior of x squared, as x gets really large to the right, positive infinity, the function f of x goes to positive infinity. It goes up. The simple function x squared, as it goes to negative infinity, the function goes to positive infinity. See that? So for x squared function, that's going to be the end behavior. If it was x to the fourth, x to the sixth, any of those even function, it's the same. See the end behavior? It's the same. And all those weird functions that you have, you can kind of boil it down to something like this. X to the third, if you notice that function, as x gets really large, f of x goes positive. As x goes negative, then x goes down. That's for cubed. Well, it works the same way with fifth, with seventh. Okay? Now, if I take this and take the negative of it, it just flips. It's the same thing. It just flips, okay? If I did the same thing with my even function, and I flipped it, let's make it positive again. That was a regular x squared function. If I put a negative in front, it just flips it. Okay? With that said, let's go back to the problem. Excuse me. You may say, what does that have to do with this weird looking thing? Well, what you do is you only look at your leading terms, and you take 6x cubed and 2x squared and you divide it. You kind of simplify it. If I go 6x cubed divided by 2x, I get, what's that? 3x squared. Well, 3x squared, well, I know x squared is simple. So 3x squared is really almost the same. It's really the same when you think of the end behavior as x gets really large. So notice, as x goes to the right, it increases, the function goes up. As x goes to the left, my function also increases there. So let's visualize what's going to be my answer. So as x goes to negative infinity, my f of x gets higher, right? Positive infinity. Both of them are same thing. As x goes to the right, it's going to be going to positive infinity. That's it. Hope that helps. Let's look at the next one. See if it doesn't look too weird. All right. This one looks a little. Now this one is suspect because notice when you divide out the leading terms, the variables cancel. So you have x cubed is gone. So really you just have the function, it's f of x to negative 4 as x gets really large or really small. So it's just going to go to f of x as negative 4 if you reduce that. And that's it. So I'm looking for negative 4, bam, on both sides. Because it just goes to that function. That's it. All right. I think that's it. This one, a little weird. When you reduce it down, notice negative will be positive. But notice you're going to have a variable at the bottom. So this was going to be 1 over x. What does 1 over x do? Well, you can look at it on the graph. You may already know. But if I go to 1 over x, the function, what's going on with this? As x gets really, really, really large to the right, it gets close to 0. See, it gets close to the x-axis. If it does the same thing to the left, it's going to get close to 0. It's the same thing. So if it's 1 over x squared, 1 over x cubed, any of those, it's always going to be 0. Always. It could be 2 over 7x. Doesn't matter. Or 2 over 7x cubed. It's going to go to 0. So that's going to go to 0. And that's going to go to 0. That's it. Okay. Hopefully this helps with this concept. Okay, last one. Let's see. This one is 9x to the 4th over 3x. Again, you're ignoring the rest of it. So it's going to be 3x. What happens to 3x? If I do my graph here, if I just do 3x, that's just a linear function. As 3x goes to the right, it goes to positive infinity. As 3x goes to the left, it goes to negative infinity. So let's see, I'm going to go back to, did I lose my function? I think I lost it. Anyway, maybe I timed out. I don't know. But anyway, the solution to that one would have been as it goes to the right, it goes to positive infinity. As it goes to the left, it's going to go to negative infinity. So hopefully that helps. If you have any other questions, please send them. I enjoy questions. And I know it's tough for everyone because you're waiting on your teacher to be there every day. But until then, we'll do our best to help. Just enjoy the learning. We're not going to be too hard on grades until your teacher gets there because we understand what y'all are dealing with. So just enjoy the learning. Learn all you can. Enjoy it. Just be diligent about it. And again, as you have questions, let me know.